Hello everyone, my name is Mikhail Dudarev. I co-founder and CTO of Lysol, and today we will talk about a concept of trusted execution and how to use this paradigm to develop and supercharge your mobile application. So before I start my talk, could I kindly raise your hands if you know and hear something about trusted applications? Wow, great. So, and my second question is, have you any experience to develop trusted applications? Cool. And if you just keep your hands and just raise another hands if you know anything about Java code. Wow. I'm super excited because initially I thought it could be a little bit a hard task to see anybody who know about this concept. So I hope at the end of my talk, you as minimum will be know more about trusted application, about trusted execution environment, and as maximum you will plan to attend our hackathon to develop great trust applications. Little bit history of myself and our company. So my journey started 25 years ago with Java card security, and I and Ivan we created a first open source product, Gcard Sim. It's a Java card simulator, and it was awarded in 2013 as Open Duke Choice Awards. It's just Oscar for open source project from Oracle company. And for these photos, you can see how difficult was our life. So it was first photo. It's exactly 11 years ago, and the last photo we made this photo on Devox UK. It was in May in the same place. So we made and making a hard job to bring security to mobile application, help developers to create unique applications with unique security features. Okay, today we'll talk about concept of trust execution environment, how Android related to trust execution environment, and which features from Android already use trust execution environment. We'll talk about the novel concept of virtual trust execution environment, and after that we'll explore an area how you can use trusted component inside your mobile application, and we quickly will go through process of develop a trust application using our Gcard Sim and talk a little bit about our hackathon. Concept of trust execution environment. So this is not like a concept which was invited, I don't know, just now or it's a year ago. It's concept was already present in any computer system. It's about isolation. So to create something trusted, we need to remove maximum influence from the external world to this component. But it's in other hands, we start to have a problem if we make some components which work in full isolation. It can't be any useful because it can't communicate to external world. It can't do anything, and this is main problem to create a trust application. It's allow this trust application to communicate effectively with the external world. We usually name the external world like untrusted world, and implement something interesting in trusted world using trust application. So concept of trust execution just allow trusted application work in isolation in secure way and implement some interesting logic. So what is trusted application? Trusted application, it's a specialized application that developed according some standards, according standards of trust execution environment, and it's allow you as application developer to handle some sensitive operation like encryption, decryption, authentication, and secure store data, etc., to perform their logic. But it's only one examples of this logic which could be used, implemented in trusted applications. So there are different interesting ways how you could implement, how to bring security in new mobile applications. So you can use trusted applications to work with some critical business logic, to implement some IP algorithms which could need work in isolation and etc. And for example, also you can, using our trust execution environment, you can develop some application to Internet of Things, to some, I don't know, device for smart home and etc. So there are a lot of area where application developers need to use concept of trusted execution environment. So we have a trusted application which implements some sensitive code. We have environment where this application allows to run, and we have API. It's named vTEE API, which allow communicate with application with external world. So main characteristic of any trust execution environment. So first, it's need to allow application run in isolation. So if we have two applications inside our execution environment, only one, if one application can't influence to another application, so they need to run in isolation. Second, it's about confidentiality. So data which owns by one trust application can be obtained by another application. Third, it's our main paradigm is integrity. So we need to identify the trusted application was not tampered, was not modified, and its whole environment is safe. Secure execution. So it means that nobody can influence to secure execution process. It's one of part of its concept. Second part concept, nobody can use different side channel attacks to understand what happens inside unit with execution. You can say, oh, it could be like a very high level abstract and very high level security concept, and we never will have see this in practice, but reality showed to us that most attacks to extracting cryptographic keys, some sensitive operation from, I don't know, from different devices like PS5 and etc., they perform it using side channel attacks. So attackers use some side channels like power analysis or just traces of your application to identify the sensitive logic of your application, and using this extract the private or secret keys from your memory. So it's absolutely a real attack to just you can say, Mikhail, you say now about some fantastic, unbelievable things, but it's real real life stories. When you just using some Volgrint, you could trace your application, and using just this software trace, use different techniques, you could understand the hot points of from your application, and you can extract the secret keys bits from this application in this moment when this software stack trace was taken. It's performed some operation with cryptographic keys. Why is concept of security execution is very important to construct and work with trust application. And of course, controlled access. So each trust application need to has access to only on their resources and not allow access to other resources. And it's a big way for trusted execution environments when they created. So first example of trusted execution environment is Java card. So do you know anything about Java card? Okay, so Java card, it's exactly, they was created exactly 30 years ago, and in idea to bring security, to bring application firewall for for any devices. So initially it started as product to develop some banking cards, and after that Java card was initially bring it to the world to bring security to each box, each TV. If you guys remember DVD, and if you maybe you have your DVD player at home, you can just look to the back of this DVD player. It's always you can find the Java card logo. So each DVD players they has inbuilt functionality with Java card. So now Java cards is in anybody phone because eSIM technology, SIM technology, banking cards, they use Java card technology and Java card operation system as a kernel to execute any operations. For example, when you make some payment using NFC terminal, what this means? That some magic happens when you put your chip card or phone in the electromagnetic field. Java card operation system is power up and special trust application selected. It's performed some security operation and returns signed cryptogram to the payment server to processing. So for this, I don't know, very quick moment, like 100 or less milliseconds, there are a lot of things happens. So, and we need to say thank you Java card for this approach, and it's one of example of a trust execution environment. So, of course, there are different another examples of trust execution environment like global platform key, which are more like industry level of type things to organize standards. So it's mainly driven by payment schemes, and it's more universal comparing to Java card, but it's also based off trust execution environment. So if we talk about implementation, we have like hardware implementation, well known ARM Transzone. So if you guys have a Samsung phone and this phone has a secure folder, it's run by Samsung Knox, and Samsung Knox technology is based on ARM Transzone. And also there are different software-based implementation. We name it vTEEs. So and we will talk a little bit later about how what's the main difference between software trust execution environment vTEEs and hardware-based trust execution environments. Here we can see a big diagram how industry standard can be terrible from the first use. So, but it's there are a lot of lines and boxes in this diagram, but what we need to take away from this diagram that we have two different words. First, it's untrusted word, very rich operation system presence, and we can trust to any components. And second is the trusted words, where some internal components of trusted execution environment exist, where trusted application live and execute, and there are different ways how these components could communicate with each other. And talking about hardware architecture, there are in this slide there are three most common schemes how this trust execution environment can be implemented in hardware. First, it's most secure, but it's most most less used in the practice because it's very expensive when we use external secure element like SIM card and etc. to perform some sensitive operation. Second approach, and it's very hard to use in practice because you need to write many interface layers to communicate with this secure element. Second approach, when trust execution environment embedded as chip on your phone. So, and it's shares some memory to communicate with your application or some kernel drivers. And the third variant, it's most common in practice. It's when it's implemented when trusted execution environment implement directly on processor. So it could be ARM Trazon, it could be Intel virtualization. So in this world, we use a special register in ARM processor to switch each operation and tell exactly processor where it's now operation executed in secure world or on an insecure world. Okay, it was a little bit sorry for these long slides with abstract diagrams, and it's not any relations to development. And now we are going to the most important part to you guys about what's relation between Android and trust execution environment. So you can say, Mikhail, it's just abstract. This is hardware. We will never use or will never plan to use some trust execution environment in practice. But my next question to you guys, have you ever used, I don't know, Android hardware key store in your application to store some secret keys or private keys? Cool. So and now I happy introduce how it works inside Android. So it's a big problem for any mobile application. It's most pain for developers to keep and work with some cryptographic operation and cryptographic keys in secure way. So, and could you imagine what could be potential risk to your application if some secret keys or private keys will be stolen from your device and used by attacker on another device to access to banking system or another sensitive operation. So, and to help developers to mitigate this problem, Google introduced in Android concept of firstly it's hardware, Android hardware key store, just way where Android guarantees that all operation with your secret keys will be performed in some isolated environment, but it's not like it just not guarantee any security. And from Android 9, Google introduced concept of Strongbox. Strongbox, it's a trust execution environment, which could be implemented as from previous slide as sharing some system resources using ARM Trazon technology, or could be implemented like independent security element. In practice, we see maybe ratio about 60% of devices support Strongbox is use some kind of TE based on ARM Trazon. Some of them use a special chip which designed to be trust execution environment. And as we see, for Android Strongbox, it's used same concept which I introduced before. So we have secure world, it's some trust execution environment on chip. Inside this secure world, it's some special trusted application developed. It's named Keymaster, which perform obviously by his name operation with cryptographic keys and etc. And we have some layer to communicate from client application to secure world. So each time when your application creates some private key or perform some cryptographic operation using Android key store on Android 9 device, and later you already use trusted application concept and concept of trust execution. And okay, you can say, oh, sorry. And maybe it's super obvious slide, but I want a little bit reminder. So to allow Android to create sensitive keys inside trust execution environment, you need to tell Android, I need to use, when you generate a new key, that I want to use Android Strongbox, and after this key is generated, you always need to check where is this key is generated, because it depends on Android implementation and depends of keys, because some keys could be supported in Android Strongbox, and some keys can be supported. It depends of Android which place keys will be generated. And now we're going to most interesting part. It's we will take a simple example and try to understand and analyze is Strongbox could help us or not to solving our problems to create some trust to work with cryptographic keys. So here is super simple example. We take some cipher and input, we use some key, and we encrypt some bytes using this cipher. So it looks good, right? So Android Strongbox guarantee to us that these keys can be extracted from secure word or trust execution element, and you just only one thing which can be public, it's plain bytes, but it's like plain bytes, we don't care about this. So we care about encrypted bytes. So in this example, it's absolutely great, and we can utilize Strongbox, and we can be sure that it's good enough for security. But if we just add two simple lines in code, if we just want to make not simple task to encrypt some data, if we want firstly decrypt data and after that re-encrypt this data by different key, and this doesn't change too much, but it's change absolutely paramount amount things for your application security. Because at the moment when we re-encrypt data, so we have decrypted bytes in application memory. And when this decrypted bytes, it's transferred from secure elements through different interfaces to application memory, it can be hooked million and dumped million times using some, I don't know, simple debuggers, FRIDA, and etc. To an attacker could obtain this data and can influence to your application process. So in this simple case, we see that concept of Strongbox is good enough to secure some primitive cryptographic operation, but it's not absolutely can be used to secure some cryptographic algorithms. So and this is very simple example. If we talk about some complex payment schemes, when we need to make some payment transaction, etc., the situation start to be more harder, and you absolutely lost control of execution of your code. And how to solve this problem? So TE is great. TE allow us to secure, generate, and store cryptographic keys. But it has some disadvantages. As minimum, as mentioned before, it's limited functionality, so it's not most of cryptographic algorithms supported. Second, it's absolutely closed platform, so if you can utilize only interface which and okay, even in Android you can't use some with communication interface with trusted application. There are different layers which transform data flow from trust application to your final application. So you can do anything, you can modify anything, you can debug anything, and also it's vendor locked. So each vendor, like Google has own TE implementation, Samsung has own TE implementation, etc. So all vendors has different implementation with different limitations. It's super complicated things. Next is performance is serious. As I mentioned before, if we talk about third type of architecture, when we use some ARM transzone interfaces, with implementation they could be quite fast, but if we talk about embedded secure elements on a device, they by design they can't be fast because it's separate processor, and also vendors try to meet Android requirements, and sometimes they put up chips with less performance characteristic, and it could create some performance issue. Next is slow vulnerability fixes. For example, if I have old Samsung 7 device and no any security patches, no any Android OS updates, if everything happens, if for example some vulnerability will be found in this implementation of this trust execution environment, nobody will deliver to end users a patch which could close this vulnerability. It's very important because if we bring something to users, we need to care about the user data, about the user sensitive data. It's problem need to solve it by developers. If phone vendors can provide a good solution to this problem. And of course, it's most painful that you can't develop anything. So you can't bring some new ideas in this interesting concept of trusted execution. And now we are going to look at what is vTEE. So sometimes it's very interesting in software development world. So some kind of terminology is not well defined, but if we talk about vTEE, it's absolutely well-defined concept from ENVCO standards. So it's vTEE, it's solutions that implemented in poor software or use little bit amount of hardware, and most important characteristic of this vTEE, it's a trusted execution environment. So it's isolation of application between each other, it's secure execution, integrity, etc. And as example of vTEE architecture, sorry for use our branding here, because it's in this moment only one real vTEE implementation that's certified by ENVCO. It's our product, so I can use this like illustration how it works. So we come with the idea to put a trusted execution environment and take the trusted execution environment from the phone, from hardware platform, and then embed into mobile application. So this means, so during integration phase, during protection phase, vTEE modules like trusted VM, which execute trusted application, some another components that in charge of secure storage, working with cryptography, are embedded into your application, and your application and the final contains its own trusted execution environment, plus trusted application that you develop by yourself, or you just use some another standard trusted application providers. What's vTEE bring to us? First, it's cross-platform compatibility. So, as by definition of vTEE, it's purely software implementation. So, with little bit parts of hardware dependence. That means so trust applications that run inside Android could, if with vTEE support on different platforms, for example, Android and iOS, they can run on both environments. Second is because it's software-based implementation, it's literally allow you to create some new trusted application based on different techniques. So you can write some native application. In our case, you can write Java applications that will utilize Java Card API to implement the functionality. Second, it's scalable, so you don't need to, because it's no mobile platform vendor lock, you can deploy it on the different set of devices from different regions and etc. And it's open to us, really open to developers, how we can influence and create some real security components to mobile application. And there are just few examples of trusted application which you could create. It's like mobile payments is most, common and obvious case, because there are some standards, they mandates any mobile payment application to follow, ENVCO specifications. It's some consorts of MasterCard, Visa, American Express, and another schemes. Second, it's most obvious is biometric authentication, because in biometric authentication schemes, we need to secure operate with some user fingerprints and etc., iris, and perform it in execution environment. Concepts which come from, DVD times it's use digital right management, and of course cryptographic key management, where we see a lot of example of trust application. And it's not full list, so there are millions way possible where a trust application could be used. So now we will talk how you start to develop trust application exactly just now without any using special proprietary tools and etc. So as I mentioned before, so our first product which we created, it's Gcard Sim. So Gcard Sim is a Java card simulator which allow developers without using a special hardware to develop and debug application, Java card application for Java cards. Why I make an accent on debugging? Because if we talk on some super hardware secure device like smart card chips and etc., after this application is deployed inside hardware chip, you start to have a limited availability to debug something and look inside what happens inside this trust execution environment, because this concept of trust execution environment don't allow anybody to look inside this trust execution environment. So it's very hard concept to develop, very hard way to developers to deep dive in this work. So and to solve this problem, we created a Gcard Sim. It's released in December 2011. We got a Oracle Duke Choice Awards, and our product has it's open source, and it's, I don't know how many stars it's has now in GitHub, but it's maybe around 1,000. But it's for this type of product, it's numbers of each star is just a real star, because these techniques is used by key players on all smart card industry markets. So, and Gcard Sim support full functionality to Java card API. It's allowed to simulate some interaction between trust application and client application. It's cross-platform because it's written in Java. And now we could see how in few steps you can use Gcard Sim API to create, initialize, and communicate with Java card application. First, we just create an instance of Gcard Sim simulator. Second, we just create some AID, just unique name of each trust application, and we tell our simulator just install this application to work with them. Next, we select this application to work, because there are many applications could be installed on same trust execution environment. You need to choose which application need to interact now, and next we need to communicate with application, and we just send some simple command, and we expect some response from this command. So in these 5 quick steps, you can see how it's easy to start to develop and use trust applications. So, okay, and if we return to our previous slide, when we are talking about some problems, some vulnerabilities in Java code for Android platform which utilize Strongbox, we just try to help to improve this code. And to write next slides, I asked ChatGPT to write, exactly asked ChatGPT, please write Java card applet based on this code, and this intellect creates some interesting code. And it's unfortunately this code contains some mistakes, so not especially this slide, but next slide, and person who can find some mistake in this code, please welcome to our booth. We are happy to present some cool presents from our company. So first, it's absolutely simple initialization logic. We just it's some kind of limitation of Java card applets to economy of memory. You just need initialize all object in constructor. After that, we in process method, and this is code where ChatGPT injected some problems, some errors. We just perform some logic to decrypt and encrypt data with new keys. And in these examples, it's all absolutely great. So data insensitive buffer is absolutely safe because it's inside trust execution environment. And second, that keys is also safe. So using vTEE, we can, using vTEE concept and concept of trust execution, we can create an different trust applications that will improve your application security and supercharge them. And now, most exciting things to us. So we decided to just announce our Lightsville hackathon as part of droidcon, and we kindly invite all developers who are present now in this room and Android and droidcon conference at all to take a part of this hackathon to develop new trusted application. So maybe you already have some ideas to create something interesting, but some platform limitations doesn't allow you to do. Maybe you just want to explore this new technology. It's not, it's new. It's very, very old technology, but they underestimated the market for decades, and because it was fully hardware based, and it's very hard to utilize this technology without special access to some I don't know, hardware and etc. specification. But now this concept of vTEE, you could easily develop, test and prototype trust application. So how this hackathon work? If you didn't scan this code before, and now it's our booth, so please scan it now, or come to our booth to talk with us, and join our webinar, which will be on December 2nd, when we'll make more detailed description about how vTEE works, how develop trust application, build your trust application, and win beautiful prices. Yeah, prices here. And it's also great that just yesterday Apple announced the new MacBooks based on M4 processor. So one of the first prizes will be laptop based on this architecture. Resources, Gcard sim, Java card documentation, global platform, and our Lightsville vTEE. I guess I am on time. Thank you very much. If you have any questions.